Okay, so SAS stands for side angle side. So if those two sides are proportional, an angle between those two proportional sides are congruent, we call it SAS. SSS means if all three sides are proportional. Then we can say they're similar. AA means angle angle. So if you have two pairs of angles that are the same, naturally the third pair would also be the same. That would also help us say they're similar. So in this case, the answer is going to be no. So don't waste your time trying to state what the similar statement is. It's going to be no, mainly because 16 and 40 and this 16 and 39, they don't line up. But if 16 over 40, is that going to equal 16 out of 39? No way. Even though these angles opposite are the same, doesn't matter. We can't say these are similar. So I'm going to say no for that one. Now here, it's a little tricky. Let's say you flip the second triangle. I'm going to flip it to make it look like this. So I mean, I know I made it a little bigger than it should be, but it's okay. You see how it got flipped, right? So that's 14, 12, and 8. Now, let's look at the proportions. I'm going to color code. Color coding is nice for us. Crap. I'm not supposed to code that way. My apologies. There you go. Supposed to color code that way. Well, that makes sense. Okay. And then okay. So let's think about it. 14 out of 84, 8 out of 48, and 12 out of 72. So first you had to reorient it in such a way so that they do line up as they should. Right now, it doesn't look they're oriented the same way. Like one's kind of much more slanted this way, and the other slanted more that way. So I flipped GHF and wrote, or yeah, not rotate. I reflected it. That's a fair way of saying it. So the ratios. What was this ratio? How much is 8 going 48? What do you multiply 8? 6, right? Is that also 1 out of 6? If I multiply 12 by 6, is that also 1 out of 6? Every single time the ratio is the same, hence the proportional. That's side proportionality. Actually, let me write it over here because I'm gonna kind of keep erasing the screen. That's always side proportionality. So that's what's happening there. Okay. Now let's look at 3. I'm going to redraw the triangle such a way like this. I'm going to draw M, L, V like this. And then the other one I'm just going to rotate like this. Also, keep this in mind. Are those angles opposite each other the same? Yeah, right. Angle MBL and UVT are the same, right? So MBL is right here, and UVT is right here. So they're in the same position, right? They're in the same position. Very important. So purple, purple, I'll use that. Purple, purple. Now let's look at the sides. 14 out of 49. And the ones in pink. 8 out of 28. How do these reduce? That's 2 out of 7, right? Same thing here. 2 out of 7. So the sides are proportional and the angles between them are the same. That's side angle side. Right? You see how you have side, angle, side, angle, side. So you're gonna see if you're saying VUT, so VUT, they're gonna say VLM. It's proportional to triangle, sorry, similar to triangle VLM. So VUT, VLM. Okay. Sorry, I gotta stay hydrated here. All right, so number 4. That's also gonna be true. So you gotta reorient as a strategy. So this one right here, I'm gonna rotate 90 degrees clockwise. So I'm gonna draw it like this. L is gonna be up top. K is right here. J is right here. Double angle, single angle, right? So K corresponds with U, J corresponds with T. So yes, we call it AA, angle. Because naturally, if that's like say 30 and 30, and that's like say 50 and 50, then these are gonna be the same also. Like 100, whatever, right? But once you have two pairs that are identical, or two pairs that are congruent to each other, the third pair has to be congruent as well. So we're going to say, if it's JKL TUV. Kind of alphabetical order there, right? It's TUV. That's what you do. There's plenty more here. I'll do 5 and 6, and then I just can't explain all these because it's going to take too long. But I could just see if you have any questions, perhaps. Or maybe do some algebraic ones. For 5, no. Because I don't have any congruence. I mean, I know these are the same. Fine. I don't know anything about the sides. They didn't give me any numbers. That's 3 markings. Do we see 3 markings elsewhere? No. That's 2 markings. I see 2 markings elsewhere? No. I have a single marking. I see a single marking elsewhere? No. So the answer is no. Now, if it were this, we have 3 markings here and 2 markings here, then I'd say yeah. And I'd say STU to SCB if you had that, but I don't have that, so. Okay, this one's a little tricky. I'm going to redraw it like this. I'm going to break off a small triangle like this. So KBC, right? Then KLM. So that's 16 and 25. That's 88. Now careful, how long's Cam, guys? 107 cm. You have to add it with KC as well. Totally not to scale. Maybe 132. So 16 over 88 and 25, 132. Those are not going to be the same. I'm almost certain. So I'm going to say no. I'm going to go check the Ansky. Yep, not similar. Some of the algebraic ones. So you're told they are similar. You have to solve for x. Actually, it's a little tricky. Did anyone have a hard time with this one? Yeah, because they didn't say exactly how they're similar. Yeah, I just realized that. That's kind of crappy, actually. Sheesh. Yeah, they should have told you straight up. I should have, darn it. Yeah, no, actually, Ms. Pro mentioned I should have actually updated schools. You forgot to do that. And watch a Little League World Series game last night. Yeah, it's a bummer. I was at Dutch Goose. It was packed. Were you there too? Oh, I didn't see you. Okay. Yeah, it was pretty neat. But yeah. Good stuff, good for Southern California. That kid could pitch, I'll tell you that. So I think for the 20, I think it's supposed to be set up like this. 5x plus 11 or 18 equals 88/24. I think that's what he wanted you to do. And then you can cross multiply and work it out. The numbers get really large, so I would strongly recommend using a calculator. I probably need a calculator too. So if I need one, you probably need one. And solve for x after that. That I'm not too worried about. Just a setup, but I think they're supposed to say that. I think they're supposed to say UST was similar to UVW. So 19, I think you could figure out, but you have to know the parallel. You have to know these are parallel, so that then these are the same and these are the same, and then they share that angle, so it's a similarity. But you have to say that first. So for 19, I think they're looking for you to do this. You say -4 plus 4x over 64 equals 36 or 96. Does that make sense? Cool. Okay, all's good. Anything else you guys want to ask about? No? Right. So here's the plan. We're going to talk about one last topic on area. I have a pack on that. We'll have to skip around a little bit because it's kind of thick. Then in the second half, we're going to review for our post test tomorrow. So tomorrow we'll have our post test. Now tomorrow, Jake did it yesterday and got it done in 40 minutes. I don't want to use all class tomorrow for it. I'm trying to think what to do tomorrow in addition to the post test. I don't know yet because I can't let you guys out early. I don't know. We'll see. Maybe we could do more review tomorrow, perhaps. I don't know. I still have your homework quizzes. I still need a grade, so maybe I could look for that. I don't know. But let's do this first. And homework is just going to be stuff from this topic today. We're gonna review for the post test. But let me pass this out first. This is that last bit of new stuff on this area. And keep my voice correct since I'm using my voice. So I have you guys do some reading. This is straight from the CCAM textbook. For those, what was that say? Oh, of course, yeah. That looks beautiful, huh? Nice. Okay. Yeah, so for those who are not familiar, CPM is a textbook we use. Those came from middle school know that. Or if you took, for sophomore, obviously you knew CPM from last year in Algebra 1. That's the curriculum we use for math at this for at least for our lower division classes. So let me pull it up first. Make sure I got it here. Downloads. Area. There we go. Sweet. Okay. So this has a lot of practice problems. It has all the answers too at the end. And we'll kind of just go do as much as we can up to about 10 o'clock or so today. See how far we get. We're not going to do all these problems. There's no way. There's so many problems here. Should we go right here, right by the Giants type stuff? I don't know if it's working. You can try it. I'll let you go first for it. Did it work? Oh, wow. Okay. Didn't sound too good, but all right. So for to give my voice a break, we'll kind of just go around the room reading. Allie, can you read that part in the box right there where it says after measuring?
Both of the area on the flat surface. Students develop methods and formulas for taking the areas of sound, parallelogram. We also find the areas with more complicated shape by partitioning than we can use the basic area formulas. Students also learn how to determine the height of the figure with respect to particular base.
Yeah, cool. So thank you. So yes, we're gonna be finding areas of all these different shapes. They mentioned triangles, parallelograms, and trapezoids. And right, we want to look at dimensions. particularly height and bases, right? That's usually what we want to do. So what we're gonna do is we're gonna figure out we're gonna label inside the base, and then we'll draw the height. So this one's gonna be pretty obvious. I'll make them my height. You just simply draw a perpendicular segment from the corner. So when you draw the height, it's basically a perpendicular I cannot spell for life of me today. Oh my God, perpendicular segment from one corner to this side. Or sorry, from the base to the opposite corner. Ah, much better. I like that. Yeah, perpendicular segment from the base to the opposite corner. That's your base. Opposite corner. Now for this one, probably easier if I draw it like this. That's my height yet again. I could have drawn it to this corner, but it's kind of weird because the base isn't. I mean, it'd been fine. I could have extended that base. Then done that. I could have, but yeah, I think it's just fine the way I did that one. For C, you draw it like this. Maybe forming a right angle. And for D, you could draw it like this. You could also draw it like this too. They're both the same. So that's how you do the height. And the base is any side you choose, by the way. Usually it's going to be something that's easy to work with. Like for a trapezoid, I would do one of the parallel sides. I wouldn't do one slanted ones. That's kind of weird. Actually, I'm not sure how you would even do that. For right triangles, just for right triangles, by the way, what if I had a right triangle? Isn't the legs automatically perpendicular by default? So then the side is a base and height's also a side. So height happens to be one of the sides. So you don't have to draw anything. It's by default already a height, just so you know, for a right triangle. And squares or rectangles, also by default too. Base and height, right? So pretty simple. Okay. Bella, can you read the part that says define how tall a person is? Yeah, sure.
Fathom stand straight up and measure the distance from the highest point on their head straight down to the floor. We measure the height of figures in a similar way. One way to calculate the height is to visualize that the shape with its base horizontal needs to slide into a tunnel. How tall must the tunnel be so that the shape will slide into it? How tall the tunnel is equals the height of the shape. The height is perpendicular to the base or a line that contains the base from any of the shapes. Highest points. In class, students also use a 3x5 card to help them draw in height. Yeah, I don't think we'll do that activity, but you get the idea. Like, yes, essentially it's just you're drawing a perpendicular segment from the opposite corner down to the base. That's all it is. And I'll read the next part. It's often easier to draw in the height of a figure when the base is horizontal, right? As I said, make it easy when the base is horizontal or the bottom of the figure. The height of the triangle right is drawn from the highest point down to the base and forms a right angle at the base. Yeah, which is exactly what I was just exactly done. So perfect. Good. Excellent. Okay. Kelsey, can you read part B?
The shape at right is not a triangle. It still has a height. In fact, the height can be drawn in any number of places from the side opposite the base. 3 heights, all of equal length, are shown.
Yeah. So we could have totally done this, right? Actually gonna have to go to a corner. So I think it's just easy to draw to the corner. That's what I'd like to do, but you don't have to necessarily, I suppose. But you can also extend it as it's shown there. So yeah, as long as they're perpendicular, I guess that's all that matters. Okay, Tina, can you read part C?
That no side is horizontal or at the bottom. Rotate the shape and draw the height as we did in pudding.
Yeah, so what we're gonna do is I'm just draw it like this, and you kind of have to tilt your head a little bit, but it'll kind of look like that. And it won't matter when you find the area because it all will work itself out. If one base is lower, then the other height will just compensate and get higher, right? And vice versa. If I go a higher base, and the height for it will be lower. It's a trade-off. So it won't really matter what you use. For example, trying to think here. What if I had a right triangle? Okay. Does that make sense? Why would that be the size of a right triangle? What theorem is it satisfying? So it starts with the P. Pythagorean, good. What's Pythagorean theorem? A squared plus equals C squared. Yep. So 3 squared plus 4 squared equals 5 squared, right? So that's 9 plus 16 equals 25, which is totally true, right? So I know it makes sense. Fine. But let's find the area of it. If I'll find the area of that, do you guys remember how to find area of a triangle? Do you remember the formula? No, it's okay. I'll show you. We're going to talk about it in a moment. It's all right. No worries. If you forgot, it's 1/2. Good. 1/2 times base times height. Why is that? Because if you think about a rectangle, base times height, what if I drew a diagonal? What is the diagonal form, guys? Is it half of the rectangle? You bet. It's half the triangle. Correct. So, yeah. So this is good for us, right? So now we know this is true. Awesome. So I just do 1/2 times 3 times 4, right? Oh, why did I put 1/3? That was dumb. Yikes. So it's 6, right? Now, what if I rotate the triangle in a way like this? What if I rotate it? So you expect the same area here, right? So where that height is would have to compensate. We would compensate. Like my base is bigger now. Clearly, it's a bigger base. So you could say, you don't have to write this down, just kind of just doing this just so you guys can see. But so my area has to be 1/2 times my base times my height. Well, my area I know is 6 when I did for 3 and 4. 1/2 times 5 times the height. If I solve the height, I should get 12/5 or 2.4. So anyhow, that's something else to kind of think about. Natalie, can you read part D, please?
Probably have at least one parallel side. Because the base is always one of the parallel sides, we can draw several heights. The height at far right shows a situation where the height is drawn to a segment that contains the base segment.
Perfect. Thank you so much. Yeah, as long as you have a perpendicular segment, that's all that matters, right? And you just draw it to one of the parallel sides. So that's a trapezoid. We see those bases there. So, sorry, those heights there. So that's pretty simple. So now let's talk about area, how to actually find these. I'm going to give you guys some formulas to work through. So you could, for a triangle, You have that. For a rectangle is that. Now for a trapezoid, I'm not going to tell you right what it is, but I'm going to help you by breaking it up like this. So you break it up that way. Um, for a parallelogram, I'll say right now, it's just kind of keep it simple. Base times height. So start the first one, part A. How'd you guys give me the area for that one? So what's that going to be? Yep. Which will be 26. Oh, by the way, we should give the units. We are very strict about that. 26 square feet. Usually when you talk like area of a house, it's always the square footage. They measure like the size of each room, you know. Okay, let's take a look at the calculate for this one here. So your base is what for part B? 8. So 8 times 13, which would be 104 square centimeters. That's 8 times 13. So I use A as my base. The 15 was irrelevant, actually. I didn't even need it. I could have used it if I've had a different height to 13, sorry, to 15, but we don't worry about it. Okay, for C, I'll call this the base. We'll call it the height. Okay. Go and try D, E, F on your own. You're going to break it up into different shapes. I might suggest for E, you could probably break it up like this. Okay, it's kind of challenging for the trapezoid one. What do you get for the middle rectangle? Oh, you get 6.5 overall? No, I'm sorry, for part D, the middle rectangle. Oh, did you do 13 times 5? You gotta do 6 times 5. Do you see why? Because 13 is this whole thing here. The middle rectangle is 6, right? 6 times 5. Oh, sorry, I was confused. Yes, it's gotta be 30. Right, right. That's gonna be 30 for the middle one. That's right, no worries. What about each of the triangles? That's a little hard to do. Yeah, I need a calculator for that one because you gotta take half of 5 times 3.5. 5 times 3.5 times 0.5. It should be 8.75 for each of them. Yeah, if you said 7.5, 17.5 means you forgot to do half. So now that should be 47.5. So the answer for part D I'll do over here is 47.5 square inches. Okay, 47.5 square inches. How about E? You have an answer for E? Yeah, you get 20 in the middle. You get 18 off to the right. And 16 over here, I think. Yeah, because the height of the middle rectangle is 4 and the base is 5. And then for the triangle off to the left is 8 times 2, and the triangle off to the right is 3 times 6. You should get do you get 54? Yeah, should be 50, and there's no units, so you say 54. Or sometimes you say square units. We don't know what they are, so just kind of arbitrarily say square units. Okay. So that's part E. And for part F, we'll only do the shaded part. So that's 28. And that's half, that's 14. And we kind of just notice it, right? Because they're all equivalent. So you get 42 for F. And again, we'll say square units. Now, coming back to the trapezoid one more time. Gosh, I've really ran out of space here. I'm going to erase some stuff from the top. Okay, for a trapezoid, you could also say this too. 1/2, both bases being added, times the height. You can kind of get away with that because what you're doing is you're taking one of the bases and chopping it up and creating these triangles. See, if I were to work that out, if I did 1/2 of 13 plus 6 times 5, 19 times 5 divided by 2, I get 47.5. So that's the end of the way you can do trapezoids. It's a formula that you can use. And it's derived from the fact that you got V1, one of the bases, times the other base reduced in these two triangles. I could go through the derivation. It's just a little complicated, but I don't feel like doing it right now. But yeah, okay. So if someone can read the bottom. So Evelyn, can you read the bottom of that page where the students have the formulas?
For part A, the area of the triangle is A equals 1/2 BH, where B and H are perpendicular to each other. In this case, the base is 13 feet and the height is 4. The side, which is 5 feet, is not a height because it does not make the base already. Therefore, A equals 1/2, 13 feet, 4 feet equals 26 feet squared. Area is measured in square meters. Wall length, such as perimeter, is measured in
Perfect, thank you. Okay, we'll go to the next page. And Pete, can you read the top? Maybe like the first 3 paragraphs on the next page?
Here, yes. I agree. Age, I'm putting it in here for A equals 13 centimeters, 1.8 centimeters, equals another or 4 centimeters. Bigger in part C is a rectangle, so the area is also A equals 40 times. In this case, you have a variable expression representing a good base and height. We still calculate the area in the same way. A equals 4x plus 1 times x equals 4x squared plus x square units. Since we do not know in what units, but some unit, we say the area is just square units. Our V showed the trap in wood. The students found 7 different ways to calculate this area. The most common way is equal 1/2. Plus 2 to inside would be 1 is other base and it's with always. And always which must be looking at the area. Like A for 1/2. 6 plus 13 times 5 equals 37.5 square inches.
Great, thank you so much. So we saw, we did this already, right? We found those areas. I forgot to put square units for part C, but make sure you put square units if we don't have units. But yeah, that all makes sense. You have the formulas there. The trapezoid you could have done without the formula, but it's nice to have it because it consolidates everything. But yeah, you totally could do that. Then we had the funny shapes. So Wagner, can you read that large paragraph there, the figures showing part C and F? Yeah.
Figures shown in parts and S are more complicated and one more formula alone will not give us the area. Part B is there, or shovel ways to divide the figures into rectangles, I'm going to show how to write. The areas of the rectangle on either end that defines as the dimensions of the one on the figure. The area of rectangle 1 is a two times a minute, 60 square feet, and the area of the rectangle is 3. Is a 3 times 6 is 62 units. To find the area of rectangle 2, do you know the length is 5? It would be good. Determine the height. The height is 2 shorter than 6, so we know the height is 4. Therefore, the area of 2, 5 times 4 is 20 square units. Now that we have know the area of each rectangle, to add them up together to find the area of the entire figure. The entire figure area is 16 plus 18 plus 20, which is 54 square units.
Awesome, thanks so much. I'll read part F. Part F, we found the area of the shaded region. Again, there are several ways to do this. One is to see as some rectangle triangle. Another way is to see the shaded figure as a tall rectangle with a triangle cut out of it. Either way will give the same answer. We see it right there, right? Okay, cool. So hopefully that all makes sense. So what we're going to do is we're going to do some problems. There's a lot of problems here. We're not gonna do all these. We're gonna do every 4th problem, I think is good. Every 4th problem. So it's 9:50. So we'll do this for about 10 minutes, take a break, come back, we'll do some more, and then we'll do that review stuff as I promised. So you're doing every 4th problem. So you're doing 4, and then all the way down that column, 8, 10, 12, 16, 20. Then 24, then 28, then 32, then 36, and then 40. 40 looks like fun. That looks crazy. I know. But let's just try right now. We'll see how you guys do. I think you guys can blast through the first few. So okay, we're doing every 4th problem. Okay. So we're doing numbers 4, 8, 12, 16, ... 40. Okay. And the answers are on the last page. I'm gonna work it out too on here. And we'll share answers after the break. But just do as much as you can until 10 o'clock, take a break, 10 o'clock, come back and do some more. So that's what we'll do. By the way, for number 4, I should have told you this. You can extend this. I'll tell you now. You got for number 4.
drop-in.
Sure, of course, yeah. So these are kind of tricky. Tell me if you guys stuck. You get well done? Just kidding. All right, let's go and take a break right now. I hear some people walking the hallways. So come back around 10:10. We'll do more of these. I'll show you some of my work.